we need to figure out what are we going to do to get this into Revit. And the first thing you actually need to figure out is how is this modeled in Revit? So if I slide that up just a little bit, so that's our single line up here. Down here, we have our model. And the question is, what does the model look like? Is this just one piece of equipment? You know, looking, we've got a wall here. We've got one piece of equipment where this is sitting on the equipment, and that's our substation. Or is this done with multiple pieces of equipment? Do we have that high voltage system? Maybe you got the transformer as a separate piece, and then the low voltage. Either of those can work. There's no right answer to how you are going to model this into Revit. It's just however you want to do that. And there's going to be implications then for what you do both on the calculation side and on the single line that we're talking about here. So if we do this whole thing, we'll start with that left side where we're doing the whole thing just as a single piece in Revit. So if I go over here, we've got this whole thing. This is just all one big item in Revit. So if you come up here to our single line, we need to have that represented by all of this. So the way we would do that is we would come over here into Revit, and we're going to take this family here and we're going to make some changes to it. So we'll take this, and it's just a matter at this point of doing some customization in Revit so things look how you want them to look. When you save that family, you need to put it somewhere that is going to be findable by ElectroBIM. So if we go back to our project here and we run customization, under user options, this is the folder where all of your stuff belongs. This is where you're saving everything to. By default, it's on your C drive. It's local to you. If you are at a company with multiple people, this hopefully is on a network drive that's being shared among all of you. If it's not, you can move it. So this is where we actually want to save this file to. So I'm going to copy that folder location, go over here. I'm going to save this file, put it in that folder, and we will call this our DME substation. And now we start doing drafting here to make this thing look how we want it to look. This graphic by default is a little bit thinner than we want it to be, so I'm just going to make the whole thing bigger. So I'm going to adjust that so that when we insert it, it just comes in as a larger size. And then over here, we need to draft all of this stuff that's on the left-hand side. So going back here, we essentially have already inserted everything in yellow. That's kind of what already exists in our graphics. So we need to draw all of this stuff over here in orange. So we're just going to draw all of that in. And don't learn your drafting from me. We're going to do something just good enough for a little bit of training. If you're doing this for yourself, take time and make this look good. I am going to at least choose a heavy line weight, and we'll draw out our section over here. And then we can put in those different sections. And now it's just drafting to get everything in here. So we're going to have our connection, then we'll make our connection point there. We can put a switch in here. This would be a transformer that you would take more time to draw nicely. I'm just going to put something in. There's my approximation of what a transformer is. You know, if you were really doing this, you take another family and copy that in, spend a little bit more time on these graphics. But for purposes of the training, that's good enough. Finally end up with that breaker that we have. And then the whole thing connects. If we zoom in on this spot here, you'll notice we've got this in. That's a connection point that we use. That tells ElectroBIM where to connect the feeder to this graphic. You probably don't want it there anymore. We probably want to connect over here. So I'm going to move this. Just going to pull it out here so it's out of the way. It's currently constrained. I'll remove all the constraints, and it's up here. It's currently has an upstream connection from the left. Let's change that upstream from above so it looks like that, and then we'll move this so it connects to that connection point. So if we actually had something upstream and it connected to it, by default, ElectroBIM will know I'll make the connection here. And then anything else you need to draft in, you just do your drafting here and you make it look right. This is good enough for the purposes of this training. We will save this file, load it into our project, and by default, it's going to prompt us to insert it. We'll just insert it and then delete it. I'm going to get rid of this transformer because it's being represented by this substation. And I can take this graphic and we can swap that out for our substation. Move this whole thing over. And we still have those pieces that allow us to adjust the graphics. So you can stretch that out. And now we have the rest of the substation graphics draft it in here. Again, make it a little bit cleaner than that. And then you can add additional text, additional labels, anything else that belongs on the substation. It's just some manual drafting. And if you want to be able to reuse it on different projects, you would create a family like this. If it's just a one-time thing, you could also just go straight here and just start drafting on top of your single line. If it's a one-time thing and you don't want to go through the work of making a family, the other option is just in your drafting view, just do the drafting straight here. So you just put the whole thing in and just draft manually yourself. The other option that we could think about is if we go back here, we've got all these different pieces. Maybe they're actually being inserted as different items in Revit. So we've got that yellow section that's the low voltage. Maybe this is a transformer that you've inserted. Maybe you're going to insert this part as its own little item. And we'll assume that this disconnect is probably going to end up on the yellow. So if we scroll back down here to what our plan view looks like, that would correspond to these items on your plan view. And then we need separate families for each of those items. You model them in Revit, and then you insert them next to each other in your single line diagram. So we'll just do that yellow and that orange section. We can do the transformer as a piece and do this yellow thing as a piece. So here, again, we'd take this one and we'd modify it. Again, make it bigger so that what comes in, it's the right size. And it's going to be just that disconnect portion. Put in the disconnect, space for the disconnect here. And then depending on how you want to do that, there's lots of different ways you could draft this. I'm going to just start here. We'll put in our breaker and then we'll move the connection point again. That's going to move it so that we break the constraints. Oh, this one's also connected. Anyway, there's a lot of stuff going on here in this family. So you got to be careful when you're modifying these. We'll take this, we'll move this here. And then if we have a connection, it's going to connect to that location right there. And I don't want to overwrite that. I'm going to save this as a new file. And again, we want to make sure that we're saving to the right spot. Easiest way to do that is go to customization, pull the location from there. We'll call this DME substation low voltage side. Load that into our project just so that we have it. And then we need this other section here for the transformer portion. We'll take this transformer family and we'll modify that so we have a better looking transformer this time. Just so that everything lines up. I'm going to copy all of this from here. Now we know that everything's going to be the same size. Maybe we don't draw anything else. Maybe it's just a really big box around it that's sized nicely. And I'm going to pull that customization folder again. Load that into our project. And now we can replace these with those families that we've created. Then you start moving stuff around so that it looks how you want. We also have this feeder that's inserted here, and it's looking a little bit wonky because we just swapped out the graphics. You could come in and run either auto draw the feeder, or in this case, I'm just going to manually redraw it. So it's really the feeder between the two sections. I'm going to redraw this feeder here, draw something like that. And then this wire is actually going to be sized, and it's included in all our calculations. So whether you draw these as different pieces is whether you want to handle that as a different part of the calculation. And maybe we don't want to have that feeder size in there. Remove that graphic. So now we just have the wire without the feeder ID. And then we have the question, how do we add any sort of labels to these? And the labeling here is what you would do for anything else with your single line diagram. It's just a matter of getting the right label. So in this case, if I select this, you can see that this family has down here all of these shared parameters. So if we want a label that has the breaker size, we need to find the right shared parameters and create a label that uses it. So in this case, that's going to be the main breaker. And so it has a mains value 600, and there's also a frame value somewhere in here as well. So if we could do an amp trips and an amps frame on that. So let's just go ahead and do that. We're going to take this label here and we will use this as the basis, because the question is always, how do you get started? It's a lot easier sometimes to just grab an existing thing and modify it. So we'll edit this family. Save this one as, we will call this DME tag main breaker. And then we need to swap in the labels that we want to have. Select the label, change the label, click edit. This is what's going to show up. And we want to add some new shared parameters because what we have is not being listed here. Right now we have all of our shared parameters listed. You probably have your own shared parameter file, so it's not going to list the ElectroBIM shared parameters. To get those to appear, what you need to do is you need to go into Manage, go to Shared Parameters, and temporarily change it to our shared parameter file. Press Browse, go to, by default, it's Program Files, Design Master Software, Electrical RT, because we haven't renamed this. That's our old name of the software, but that's where it's stored. And then you choose your shared parameter file. There's slight changes as the versions of Revit change. So choose the oldest one that you're using, typically is what you want to do. And then this will pull in our shared parameters. While you're making changes, have our shared parameter file loaded. If you are using your own, then you can come back here and change it back when you are done. It doesn't really matter. Revit, it matters because that's what it's going to pull from. Revit doesn't care if you're changing it back and forth on it. Once it's loaded, the shared parameter doesn't actually use this file anymore. So this is the basis of that shared parameter file, but then once it's loaded, it's in the project and it's not looking here anymore. So you can change this all the time and it doesn't impact anything that you're doing in your projects. Pull the mains value is actually a Revit value. So we'll go to the Revit duplicate. So we'll load in the mains. So we have that as a value, and then we'll pull the trip value. Actually, since this is the main breaker, it's not the bus size, it's the breaker size. So we'll pull in the breaker values. All right, so we'll pull the main disconnect trip size, and we will also pull the main disconnect frame size. Get rid of all of these and use just those newest ones that we added. So we'll do amps trip, amps frame. We'll do a break on those two. And we're actually going to do one more thing. We'll add a suffix. This one will say trip. This one will say frame. Load that into the project. Apply it to this panel, which is main lugs only right now. And then we would come in here, and if we run our edit and actually set a size for that, we can change this to have a main breaker. All right, so it's got the trips in the frame. Okay, I forgot how that was labeled. We actually want to do the AT and the AF. So we'll go back and change that. We want to change this suffix to say amps trip and this to say amps frame. Load that into the project. That's the label we want. Get rid of the leader line. Move this where it makes us happy over here by that breaker. So now we have that. It's linked up to everything else you're doing with the software. That's what you want to do. And that's how you can handle Switchgear with more complicated graphics than what we provide out of the box. It's drafting it in there as families, as stuff on the single line, multiple families, one family, depending on how you're modeling things and what you want this to look like. For this family, you'll also notice that when we added it, set it to a main breaker, it also put the main breaker over here. That's because of how our families are created. So if you are using our families, you'll want to modify that so that that doesn't happen. And I'm trying to think the simplest way to do that. If we take this family here, we have a bunch of visibility controlled parameters, and it's based upon the main disconnect type. In this case, if we just force those to always be off, that's probably going to be your simplest way to handle that. So we have the main lugs only. You want to have that visible, and then you want to just have this one not visible. So I'm going to get rid of that formula. And then there's also a fuse switch. We're going to get rid of that one as well. So if you get rid of those, and now, okay, we don't have this breaker happening over here anymore. How will this be represented and shown on the floor plan? That comes back to here, where you have two options, either as a single device or as multiple devices. We don't do anything in our customization with your floor plan devices, so you will need a substation family for inserting in your model. We're talking strictly about the single line. That's the graphics we provide. That's the graphics we're trying to get right. The model family is one that you're going to need to pull from a manufacturer or from your own library. And then you can do it as a single device or as multiple devices. How does this impact the fault calcs and voltage drop when doing custom pieces of equipment? This will depend on what you are doing with the number of pieces of equipment. So if we go up here and we put in one more section, we have our single line, we've got what's happening on the model, and then we also have what's happening in the calculations. And again, there's two ways you can do it, because how you model it on the floor plan is going to impact how you do the calculations. Here, you're just going to have a single sub node on your calculations. And then anything coming off of this, if you've got various panels, are going to connect to it. And if there's a utility transformer up here, it's just going to have a single connection to that. So you will have a single point here for voltage drop and fault and everything else. It's not going to do any calculations through it. It's basically going back up here. You're going to be working in this green square. You've kind of got the value up here at the top, and then you're going to have your value essentially at the top of your secondary. And those are kind of the two places where any sort of calculations are going to happen. And anything that happens in the middle is going to be ignored by our software. So if you need to account for anything, it's not going to do that. So you just have to be aware of that. Alternatively, you can model it as three separate items, like we have on the right-hand side here. So here, instead of having that single sub, you'd have HV going to T, going to LV, and then you'd have your panels and the utility to have the same model. So this whole thing is kind of that box and that box are corresponding to the same thing. It's just three versus one item being represented there. Going back up to the single line diagram, if you do it as those separate pieces, you'll then have each of these items and you'll have calculations again at the top and then at each of these locations here. And so then you can account for that for the calculations for fault and voltage drop. Again, what you do depends on what you're trying to get out of the calculations. If you need to take that into account, or if you don't want to try and model all of that. There's no necessarily right answer. Just understand your options, and then you as the engineer need to figure out what information you have, what you need to figure out. When placing an ATS as the main disconnecting means on the switchboard, would you insert an actual ATS or create a new one and drop in two connectors? Again, it's a question of how you want to model that. Both ways could work. So you have to come in here and in Revit, think about what pieces you're going to insert, and then how you want that to be drafted on the single line and what you want to have happen on the calculations. I mean, in terms of simplicity, if you have an ATS family, it's probably easiest to insert a switchboard, insert the ATS, connect them up. Otherwise, if the ATS is kind of embedded in that switchboard, you would have to go modify the switchboard family to add the second connector, which could work. It's just modifying that family. Then you have a family with a switchboard with two connectors rather than just one. It depends, I guess, on how often you do that. If it's something that you do regularly, a switchboard with an ATS embedded would be a useful family to have if you're going to use it on a couple projects. If it's just a one-time thing that you're only seeing once, I would just do a transfer switch and a switchboard, because it's going to be way simpler and you just move on with your life in the project. Because while we can do all of this customization, getting the customization right, getting these graphics right is a little bit fiddly. Getting the families to work right is a little bit fiddly. So if you can stay away from having to do any of that, you're going to be better off. So you don't have to mess with all of that. So if you are messing with that, make sure it's something that's going to be valuable and useful beyond a single project.